Good morning, my students and listeners at home. My name is Mrs Chioma, a teacher from Physics Department, St. Charles College, Onitsha. My topic today is transformers. The specific objectives. By the end of the lesson, the students will be able to 1. Define a transformer. 2. List types of transformers. 3. List the energy losses in a transformer. And 4. Solve some mathematical examples on transformers. Now let's go into the lesson proper. Yes, we are talking about transformer. We see transformers in our various locations. In our street, in our school, we have one here. Have you ever asked yourself what a transformer is used for? A transformer is an electrical device for changing the size of an alternating current voltage. It acts either to increase or decrease the EMF or electromotive force of an alternating current. Let's look at the structure of a transformer. A transformer consists of 2 separate coils, the primary coil and the secondary coil. The primary coil is called the input coil or the input winding, and the secondary coil is called the output coil or the output winding. These coils are wound round the soft iron core. The soft iron core has to increase and concentrate the magnetic flux within the core. This soft iron core is laminated. It is laminated to reduce energy loss due to eddy currents. We have 2 types of transformers. We have the step-up transformer and the step-down transformer. We can differentiate between these 2 types of transformers by the coils in their secondary winding. The step-up transformer. In the step-up transformer, we have the primary coil, which is wound around the soft iron core. The primary coil is called the input winding. Both the primary and the secondary coil are wound round on the soft iron core. In the step-up transformer, the secondary coil is small, while the primary coil is less. Then we have the step-down transformer. In the step-down transformer, the number of turns in the primary is more than the number of turns in the secondary. According to their names, the step-up transformer is used to step the voltage of an alternating current when it is high. Assuming you are in your house and you receive very high current, you will notice that the high current will spoil a lot of things in the house. That means the alternating current was supplied without stepping down. What the transformer does is, when the current is received very high from the supplier, it is now stepped down so that it can now be normal for usage in our homes. But when this current is too low for usage in the homes, the transformer also steps the current up. So that is what the transformer does. It either steps down the current or step up the current when it is low, or step it down when it is high. Let's look at the principle of operation of a transformer. A transformer works on the principle of mutual inductance. What is mutual inductance? Mutual inductance is the flow of induced current in a coil due to an alternating or varying current in a neighboring coil. Yes, when an alternating EMF or current is applied at the terminal of the primary coil, an alternating magnetic flux is produced in the core. Because the core links the primary to the secondary, an EMF is induced in the secondary. This EMF that is induced in the secondary depends on the number of turns in the secondary. If the number of turns in the secondary is low, the current goes down. That means the current is stepped down. But if the number of turns in the secondary coil is more than the number of turns in the primary, the current is step up or goes up. So that is how a transformer works. I know you will be asking question whether these two transformers are in one case. Yes, the ones you see in the street, both the step up and the step down are there. What the transformer does is that it controls the current when it is high and controls the current when it is low. Let's look at the formula of a transformer. The formula of a transformer is ES over EP is equal to NS over NP. ES is the EMF in the secondary and EP is the EMF in the primary. NS is the number of turns in the secondary and NP is the number of turns in the primary. The above relation is very important transformer law. In ideal transformer with 100% efficient, the power developed in the secondary is equal to the power developed in the primary. We can say that from this law. IS times IES is equal to IP times EP, where IS and IP are current in the secondary and current in the primary. We can also restate the law as ES over EP is equal to IP over IS. From this equation, we now have ES over EP is equals to NS over NP is equals to IP over IS. This is the formula for a transformer. I hope we are going to solve some problems on this. Before we solve some problems on transformers, let's look at energy losses in a transformer and ways of reducing it. When a transformer is working, a lot of energy is lost. We have these energy losses in form of eddy current, which can be reduced by laminating the soft iron core. We have the hysteresis loss, which can be reduced by use of soft iron core. We have energy loss due to heat, which can be reduced by use of low resistance coil or thick wires. Then we have energy loss due to leakage of magnetic flux, which can be reduced by efficient core design. Efficiency of a transformer. We've just mentioned about energy losses in a transformer. I said that in a practical transformer that it is less than 100% efficient because of these energy losses. The efficiency of a transformer can be defined as the output power, which is also called the power in the secondary coil, all over the input power, which is also called the power in the primary coil, times 100%. Example 1. Find the turns ratio in a transformer which delivers a voltage of 120 V in the secondary coil from a primary voltage of 60 volts. The turns ratio is given as NS over NP. NS is number of turns in the secondary coil and NP is number of turns in the primary coil. The formula for a transformer is ES over EP is equal to NS over NP. 120 is the EMF in the secondary and 60 is the EMF in the primary, which is equal to NS over NP. 120 divided by 60 is 2. So the turns ratio is 2 or 2:1. Example 2. A transformer has 500 turns in the primary coil and 300 turns in the secondary coil. If the primary coil is connected to a 220V mains, what voltage will be obtained from the secondary coil? What type of transformer is this? Solution from equation or the transformer formula. We have ES over EP is equal to NS over NP. We are looking for ES in the question. Our EP, which is the EMF in the primary, is giving us 220V, sorry. Then our NS is giving us 300 turns. And MP is giving us 500 turns. So we now have ES is equals to EP times NS over NP, which is 220 times 300 over 500, which is equal to 132 volts. We are asked in the question, what type of transformer is this? We can answer the question in two ways. By looking at the EMF we have. The EMF from the solution of the secondary coil is 132 volts, while the given EMF is 220 volts. So we can answer the question that the EMF in the secondary is less than the EMF in the primary, which means that the transformer is a step-down transformer. Or by the number of turns. When we look at the number of turns in the primary, which is greater than the number of turns in the secondary, we also know that it is a step-down transformer, because in a step-down transformer, the number of turns in the primary is greater than the number of turns in the secondary. My dear students and listeners, I hope you enjoyed the lesson because I've almost rounded up. I want to use these questions to really know if you understood what I have taught. Number 1 question is, define a transformer. Number 2, list types of transformers. Number 3, list the energy losses in a transformer and ways of reducing it. Number 4, a transformer can produce 20V from a 240V supply. If the efficiency of a transformer is 80% and the current in the secondary is 10A, calculate the current in the 240V supply. Give 2 reasons why a transformer is not 100% efficient. Dear students, you can answer these questions and send your answers to me through my WhatsApp number, which is 080-233-54594. Thank you and God bless you for listening.